Hello everyone, here is another interesting question from the New Zealand Chemistry Olympiad. Considering only structural isomers, what is the number of alcohols of each type with the formula C5H12O? This question is somewhat involved in the sense that first we need to write down the correct number of alcohol isomers, and then we should consider only structural isomers. Then we can figure out how many of them are primary, how many of them are secondary, how many of them are tertiary. We know that C5H12O is a completely saturated elemental composition with a degree of unsaturation value equal to 0. This means that no double bonds are possible. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2. This will be 1 plus 5 minus 12 by 2, and that will be 0. Therefore, we don't have to worry about cyclic structures or double bonds in this case. Let us write down the structures one by one, and then we will try to find the correct number of primary, secondary and tertiary alcohols. We can definitely write pentane 1-ol, 1, 2, 3, 4, 5, and then the OH group. This is pentane 1-ol. We can also write pentane 2-ol, 1, 2, 3, 4, 5, OH group at 2 position. This is pentane 2-ol. And then number 3, we can also write pentane 3-ol. This is pentane 3-ol. We cannot write pentane 4-ol because that would become a repetition of pentane 2-ol if we do the numbering from left to right. Therefore, we should not write pentane 4-ol. We are exhausted with the pentane chain. So, let's go to the butane chain. 1, 2, 3, 4, and then the alcohol, and then the methyl group. 1, 2, 3, 4. This is 2-methyl butane 1-ol. Then number 5, we can also write 3-methyl butane 1-ol. So this is 3-methyl butane 1-ol. And then we can also write 2-methyl butane 2-ol. Let's write the butane chain first. 1, 2, 3, 4, and then the alcohol, and then the methyl group. This is 2-methyl butane 2-ol. And then number 7, we can also write 3-methyl butane 2-ol. So let's write the butane chain first, and then the alcohol functional group at 2 position and the methyl group at 3 position. This is 3-methyl butane 2-ol. And then number 8, we are exhausted with the butane chain, and now we are going to the propane chain. 1, 2, 3, put both the methyl groups at 2 position and then the alcohol functional group. So this is 2, 2 dimethyl propane 1-ol. The reason why we did not put both the methyl groups at 1 position is because that would become a repetition of 2-methyl butane 2-ol, and that's the reason we put both the methyl groups at 2 position. Anyways, these are the 8 alcohol structural isomers that are possible for C5H12O. And the reason why they want us to consider only the structural isomers is because we have a chiral center here. This is a chiral center, and then in another case too we have a chiral center. This is a chiral center. Therefore, we should not consider that. We have to consider only the structural isomers here, not the stereoisomers. So let us find out which one is what type. So in the case of pentane 1-ol, this is a primary alcohol because the carbon atom bearing the OH group is directly connected to only one carbon, and therefore this is a primary alcohol. In the case of pentane 2-ol, the carbon atom bearing the OH is directly connected to two other carbon, and therefore this is a secondary alcohol. Likewise, the same is true for pentane 3-ol. This is also secondary alcohol. 2-methyl-butane 1-ol, this is once again primary alcohol because the carbon atom bearing the OH is directly connected to only one carbon. We should not worry about this carbon atom. And then 3-methyl-butane 1-ol, this is also a primary alcohol. And then 2-methyl-butane 2-ol, this is a tertiary alcohol because this carbon bearing the OH is directly connected with the three other carbon atoms. Therefore, this is a tertiary alcohol. For number 7, this is a secondary alcohol because the carbon bearing the OH is directly connected to two other carbons. And then for isomer 8, this is also a primary alcohol because the carbon bearing the OH is directly connected to only one carbon. So we have how many primary alcohols? We have one here, another here, another here, and another here. We have 4 primary alcohols. How many secondary we have? We have one here, another here, and then another here. 3 secondary alcohols and only one tertiary alcohol. This means that option D is correct.